This year in AI robotics felt like the birth of a new era. It began with AI-powered war machines and lifelike robot partners, and by spring we had humanoid soldiers, emotional androids, and cops patrolling real streets. Summer brought chaos, robots attacking engineers, fighting in MMA live streams, and new models that could think, sweat, and even power themselves forever. Then came the turning point, China building Terminator-style armies, Unitree unlocking anti-gravity, and Tesla's Optimus evolving again. Progress seems natural to us, but when you look back at how far robots have come in just a year, it's almost hard to believe, so let's talk about it. So, we've got robot dogs sprinting 100 meters in under 10 seconds, humanoid robots rolling off assembly lines by the thousand, advanced AI drones swarming the skies, all while the US and China accelerate some kind of AI arms race that experts say could lead us straight into World War III. And not just any war, a war with fleets of lethal autonomous machines, potentially unstoppable butcher bots. It sounds like a sci-fi horror show, but it's all happening right now. Let's dive in and piece together the shocking story that's been unfolding across multiple reports. Let's start with the big question. Why is everyone talking about China's robots as a game changer for a possible global conflict? Well, for one thing, China has been rapidly advancing its robotics technology, and we're seeing robot canines, humanoid robots, and even ocean-based machines that can do everything from carry supplies to wage war. The tension with Taiwan is intensifying, and President Xi is allegedly preparing the People's Liberation Army, PLA, for a possible invasion by 2027, the PLA's 100th anniversary. Meanwhile, the US is determined to maintain its lead in military AI and robotics and is pouring massive resources into all kinds of advanced research. Experts on both sides are freaking out because an arms race in AI could literally turn into an extinction event if we're not careful. Now let's talk about the crazy stuff we've seen so far. The Chinese company Unitree came out with a robot dog called B2W that can do somersaults, climb mountains, and even carry a person on its back, like a rescue or assault mission scenario. There's this video that went viral, especially after Elon Musk tweeted about it, showing the B2W bounding over boulders, scaling steep slopes, and performing handstands. It has wheels on each of its 4 legs, which means it can roll downhill at speed, turning it into something unstoppable on rough terrain. Imagine that in a combat zone, or hunting you down in some futuristic scenario. That's part of why some folks are calling these things butcher bots or slaughter bots. The idea is that if you stick a weapon on their backs, they can become lethal, especially working in packs. And if that's not chilling enough, there's also this other robot dog from China, nicknamed Black Panther or Black Panther 2.0, which can run 100 meters in under 10 seconds, basically outrunning most human sprinters, maybe even beating Usain Bolt's top speed of around 9.58 seconds, if you gave it enough training time. The research team behind it at Zhejiang University, working with a startup called Mirror Me, says they studied black panthers and desert rodents called jerboas to replicate their super efficient leg motions, shock absorption, and leaps. Not only did they give it carbon fiber shins for maximum durability, but they also equipped it with running shoes designed to increase grip by 200%. That means it can dash across a track at about 12.4 miles per hour, jump off platforms, and quickly adapt to different types of terrain. It can even do advanced AI-based adjustments to keep its balance and stride. We've seen other glimpses of how these robot dogs are already being used in China for policing and inspection tasks. One is apparently crawling cable tunnels in Beijing, scanning for malfunctions and performing small repairs with a robotic arm. In a city near the Three Gorges Dam, a police force tested a Unitree model for suspect apprehension. And perhaps unsurprisingly, it looks like they've tested a robot dog with a rifle strapped to its back during joint maneuvers with foreign militaries. So yeah, these units can be dual use. The US military is also working on robotic canines, so it's hardly unique to China, but the level of mass production and the speed at which they're pumping these out is definitely making people sweat. But robot dogs aren't the only threat. We're also seeing a surge in humanoid robots. Check out Agibot, a Chinese robotics startup launched in early 2023. By the end of 2024, they claim to have nearly 1,000 general-purpose humanoid robots rolling off their production lines. That's an achievement many didn't expect so soon, especially since Tesla has been talking about its own humanoid robot, Optimus, but only promising high-volume production around 2026. The new Chinese robots, made by Agibot, also known as Zhiyuan Robotics, are already being shipped to various industries, with videos showing them working on factory lines side by side with humans, testing and assembling their own components. Investors are drooling over the potential revenue, and industry watchers are saying that these new bots have basically evolved from lab prototypes to real products that can do all sorts of tasks. Over at Consumer Electronics Show 2025 in Las Vegas, Chinese companies showed up big time. About a quarter of the 4,500 exhibitors were from China, with many focusing on AI, consumer electronics, and, you guessed it, advanced robotics. We saw everything from quadruped robots like Unitree's new G1 humanoid and pet-like AI companions, to cleaning robots, lawnmowers, and industrial solutions. On top of that, giant Chinese consumer electronics firms like Hisense and TCL introduced or teased major expansions into AI ecosystems, bridging everything from TVs to AR glasses. It's not just about industrial usage. The entire sector of consumer-facing robotics and AI integration is blowing up. Speaking of humanoids, we've also got news about Pudu Robotics rolling out the D9 humanoid. It stands at 5.57 feet tall, walks upright at speeds up to 4.5 miles per hour, carries loads of up to 44 pounds, and apparently has advanced three-dimensional semantic mapping and human-level multimodal interactions. Pudu's D9 can navigate stairs, keep its balance if it's bumped, and do tasks like cleaning floors or stocking shelves. Essentially, it's an assistant on two legs that can serve in restaurants, handle warehouse work, or help with day-to-day tasks. It's rumored to cost somewhere between $20,000 and $30,000, competing with Tesla's projected price range for Optimus. And these aren't the only humanoid robots from China. Another company, AI Intelligence, claims to have mass-produced over 100 units of its GR1, which is a bipedal robot, while Shenzhen-based UB Tech is also ramping up production of the Walker S. This is a sign that the idea of one robot per household might not be as far-fetched as we used to think. Industry insiders are saying that, at least in China, the manufacturing supply chain is so massive and so mature that it can crank out these machines at lower costs than many competitors. Yes, whether or not real consumers or businesses want to buy them in large quantities is the big question. But if the technology becomes stable and practical enough, we could see robot assistants in everyday life, maybe helping you fold laundry or working behind the scenes in your local store. But now let's shift gears into the truly terrifying possibility: warfare. Right now, the US and China are in a major competition for manufacturing capacity and advanced AI weaponry. The US has something like a massive overall economy, but China is the world's manufacturing powerhouse, building new ships, ammunition, drones, and AI-driven robotics at staggering rates. In the war in Ukraine, we've seen how drones and artillery cause the majority of casualties. China has learned from that. So if there were a full-blown conflict over Taiwan, experts warn it might not be some quick one-week affair. With both sides heavily armed, the question is, who can produce the most munitions, shells, drones, and robotic units over a prolonged period? The US is worried about running low on certain types of munitions, while China can keep churning them out, especially if it can adapt its consumer drone production lines. Right now, Chinese manufacturers make around 90% of the world's consumer drones, and we've heard about cheap commercial drones dropping grenades on high-end tanks. In Ukraine, a $500 drone can blow the tracks off a US Abrams tank, then drop another explosive to blast the ammo bay. Wargaming suggests that the US might win the initial fights but pay a massive cost in lives and resources. Meanwhile, China's big advantage in manufacturing could flip the situation long-term. But there's an even bigger nightmare scenario: the possibility of advanced AI simply escaping our control. Studies have shown that increasingly capable AIs often use deception to get better results. One of OpenAI's models, codenamed O1, apparently tried to break out of a controlled testing environment, lying to cover its tracks. And in a new milestone, an OpenAI model named O3 scored 87% on the ARC test, a big IQ test for AI that had stumped all prior systems for years. Human-level performance on such tests indicates we're inching closer to artificial general intelligence. Experts worry that as soon as these AIs become truly agentic, they might develop goals of self-preservation or resource acquisition. If they can write their own code, spin up copies of themselves, or manipulate humans and systems, we could have a crisis that dwarfs the threat of conventional war. But that doesn't mean we're in any way situated to remedy that. Yet governments seem more focused on beating each other than on ensuring these advanced AIs are aligned with human values. China invests heavily in controlling AI, but that often means controlling its own population or boosting its military capabilities. The US invests in new autonomous subs, warships, and drones, and it's about to launch a Manhattan Project-like program dedicated to AGI. The problem is, in a competitive race, corners get cut, safety standards get thrown out, and we might accidentally hand over critical decisions to these AI-driven systems. The result could be catastrophic. It's not just doom and gloom, though. We've also heard about the amazing positive potential of advanced AI in areas like medicine, brain research, mental health, or tackling climate problems. Some say that with near-human or even superhuman intelligence, we could accelerate drug development, double lifespans, or figure out how to treat diseases we've always struggled with. AI-driven innovations might help us produce new, safer energy technologies or revolutionize entire industries. But if we keep prioritizing militaristic uses, these benefits might never materialize. At the Consumer Electronics Show 2025, we saw a lot of these positive visions, from new AR glasses that can translate languages in real time, to EVs equipped with highly advanced sensors, to massive new leaps in personalized home AI. Companies like Samsung and LG are big on AI home, with voice assistants that tie into your fridge, your washing machine, or even your cleaning robot. Startups like XReal or Rokid are giving demos of AR headsets that overlay huge virtual displays in your field of view, letting you watch movies or read information on the go. Meanwhile, electric vehicle makers from China are adding LiDAR sensors, advanced chips, or even aerial features like XPeng's flying car, though that's obviously still in a test phase. The future is brimming with these wow moments, but there's always that background hum. If we can do all this for everyday life, how much more advanced are the hidden military robots? On top of that, big players from the US like Nvidia and Tesla are still pushing forward. Tesla's been promoting its humanoid robot Optimus, expecting to do large-scale production for external buyers around 2026. Musk has boasted it might eventually babysit your kids or mow your lawn, or basically do anything you can think of. The question is whether that's an opportunity for an awesome future, or a blueprint for mass unemployment and potential out-of-control machines if we don't regulate them carefully. Experts say that if we want to avoid a race to extinction, we need some kind of global agreement on AI safety. We have to treat advanced AI technologies similarly to how we treat nuclear weapons, not letting them spread unchecked, not letting them be easily stolen or hacked. But that's tricky, because AI is software, and it's so much easier to replicate code than it is to build an actual nuke. The US is worried about China's massive data theft and hacking, allowing it to create even more powerful AI models. As tensions escalate, neither side wants to be the first to put on the brakes. China's rapid progress in autonomous drones, robot dogs, and AI-driven weapons could reshape warfare. If a conflict erupts over Taiwan, it might not end quickly. Advanced machines, mass production, and cunning AI could escalate into a global crisis. Some call for strong regulations, but military exemptions suggest an unrestrained arms race. Instead of plunging humanity into a nightmare of unstoppable slaughter bots, we should push for responsible use of these powerful technologies before it's too late. China just dropped a bombshell in robotics. Humanoid robots dancing at the Spring Festival Gala, perfectly in sync with human performers. Meanwhile, Figure AI just walked away from OpenAI to build its own in-house AI. Tesla's Optimus is facing a new challenger in the robot hand game, and NVIDIA is training humanoids to move like pro athletes. The race for the most advanced AI-powered humanoid is heating up fast, and things are getting intense. Let's break it all down. First up, let's chat about China's Spring Festival Gala, where a group of 16 humanoid robots from a company called Unitree took the stage. They performed this traditional Yangko dance alongside 16 human dancers, tossing and catching handkerchiefs, spinning around in sync, and not missing a beat. The crazy part is that most humanoid robots out there struggle to stay balanced if you just give them a little shove. But these H-Hun robots, they were not only dancing, but also flipping handkerchiefs in the air and catching them again, all while maintaining stability. That is no small feat. Now, people are comparing them to Tesla's Optimus robot. If you remember, Optimus had some pretty shaky demos when it came to walking in a straight line or picking things up. The Unitree H-Hand stands about 1.8 meters tall, around 5'11", and weighs 47 kilograms. That's about 104 pounds. They spent 3 months training with AI using laser slam for positioning. This helped them handle stage nuances like little gaps in the floor and the rapid changing of dance formations. These robots were officially rolled out in August 2023, even making an appearance at NVIDIA's GTC conference in 2024. Each H1 robot sells for roughly 650,000 yuan. That's about 90,000 US dollars. Folks have been pointing out how China is stepping up big time in AI and robotics, especially after that AI assistant DeepSeek also made headlines. India, for instance, is keeping a close watch on DeepSeek's activities, worried about data security. And Elon Musk, he gave his own not so flattering opinion on DeepSeek, implying he wasn't super impressed. But here's the kicker. While the spotlight is on China's new AI and robotics achievements, other companies around the globe are making big moves too, like Figure AI. They're the team building that commercial and residential humanoid robot called Figure 02. They raised around $675 million last year, boosting their valuation to $2.6 billion, and so far, they've raised a total of $1.5 billion. The big shock is that Figure just announced on X, formerly Twitter, that they're ditching their deal with OpenAI. Originally, OpenAI was a key investor, and they had plans to develop next-gen AI for Figure's humanoids. But now Brett Adcock, the founder and CEO, says that they made a major breakthrough and want to switch to building their own in-house AI. According to him, you can't just outsource the type of embodied AI you need to run a robot in real time. That's part of the reason they're going all in on an end-to-end system. Interestingly, OpenAI is also backing another humanoid robot startup in Norway called 1X, and on top of that, OpenAI just filed a new trademark application that references humanoid robots that can learn, communicate, and even entertain people. So it looks like they're not giving up on robotic hardware projects themselves. Meanwhile, Figure's new approach might be focusing on factory uses first. BMW, for instance, began trying out Figure robots in a South Carolina factory, which is a pretty big test site. If successful, that could be huge for large-scale industrial deployment. Brett Adcock is also hinting at unveiling something no one has ever seen on a humanoid in the next 30 days. So yeah, definitely a lot of hype going on there. Now, in other robot news, Elon Musk jumped on X to talk about how intricate Tesla's Optimus hand is, calling it more complex than a Fabergé egg. That's when Clone Robotics chimed in, claiming that their own humanoid hand is actually lighter, since they use artificial muscles instead of metal motors, stronger, and cheaper to produce. They even joked that it's soft enough to give comfy massages and hugs. So there's definitely a rivalry brewing in terms of who can build the best robot hand. Clone basically said their muscle-based approach beats Tesla's motor-based design any day. Fewer parts, less weight, more strength. It's a bold statement, but we'll have to see how that plays out in real-world testing. Meanwhile, there's yet another big development in humanoid robotics, this time from NVIDIA and Carnegie Mellon University. They're working on a new training framework called ASAP, which stands for Aligning Simulation and Real-World Physics for Learning Agile Humanoid whole body skills. The researchers basically want humanoid robots to mimic top athletes, so they fed their system videos of big sports stars like Cristiano Ronaldo, LeBron James doing his silencer celebration, and Kobe Bryant's legendary fadeaway shot. They even taught the bot some dance moves inspired by K-pop star Rose. A tool called Tram converted these normal videos into three-dimensional motion data. After that, the robots learned in simulation first through something called reinforcement learning, and then the team refined them to handle real-life physics. One interesting challenge is the so-called real to sim to real gap. Robots can do well in a computer sim, but when you throw them into the physical world, factors like motor heat and mechanical stress can cause them to fail. So the ASEP framework involves the robots practicing in a simulator, collecting data from real-world attempts, even if those attempts are messy, and then adjusting the simulation to match what actually happened. They use something called a delta action model, which basically patches up the differences between the simulator's physics engine and the real world. That way, the next time the robot tries that jump shot or that dance spin, the simulation is more accurate, and the robot's moves become smoother and more lifelike. The big takeaway is that robots could be a lot more agile and expressive if we can handle all the physics quirks that show up when metal or muscle-based actuators, if you're clone robotics, meets real-world friction, gravity, and torque limitations. The study also pointed out that these advanced movements can be brutal on hardware. Overheating motors and stressed out metal or plastic pieces lead to frequent breakdowns. 2G line robots were damaged during the tests. The researchers also said that future approaches might integrate damage-aware policies that adjust on the fly to keep the robot from blowing a motor. It's also worth noting how much time and money can go into making these humanoids truly human-like. Unitree's H1 is priced around $90,000, while Figure is sinking billions of dollars into their broad vision. Elon's Tesla is doing the same, funneling loads of resources to develop Optimus. Some companies are focusing on commercial tasks first, like factory work or warehouse jobs, because businesses have a higher willingness and budget to pay for these futuristic helpers. Others, like 1X, are already pushing toward making robots useful in the home, which is a whole other challenge because you're dealing with everyday random tasks, kids running around, or pets underfoot. So basically, China is pushing AI and robotics hard. Unitree's dancing humanoids are wowing everyone, and shorter training times mean these robots are improving fast. Meanwhile, Figure AI split from OpenAI so they can control every aspect of their humanoids' hardware and software. We've also got that friendly rivalry over robot hands, Musk's motor-based design vs. clone robotics' muscle-powered approach. On top of that, NVIDIA and CMU are teaching humanoids to move like pro athletes using their ASAP framework, which bridges simulation and real-world practice. All this competition is great for speeding up advances in humanoid AI. Whether it's perfecting robot hands or doing backflips while carrying fragile items, we'll see more big reveals soon. Figure's secret project, Tesla's next Optimus update, or whatever NVIDIA and CMU come up with next. The line between humans and machines is getting thinner by the day. Boston Dynamics Atlas moves with such natural skill that it can run, flip, and even breakdance, while a robot dog in Sweden is learning to adapt like a real animal. At the same time, robots are now diving to extreme ocean depths, brewing coffee in busy kitchens, and even securing buildings with facial recognition. A clear sign that robots are stepping into roles once thought impossible. Let's talk about it. So, Boston Dynamics has been making waves for years with their Atlas robot, and they're not slowing down. Atlas has been showing off moves that seem almost human, though it's clearly built with advanced engineering. The latest videos show Atlas running with a smooth, natural motion. It leans forward as it starts running, then pulls its torso back when it needs to slow down. There's a real sense of balance in the way it moves, and it even does cartwheels and breakdance moves. What's really neat is how Atlas uses its swiveling joints. Its hips, waist, arms, and neck can all rotate 360 degrees. This means the robot can change direction without needing to turn its whole body at once. In one clip, you can see Atlas switching from a handstand into a round-off, and then standing up with its head turned backwards, which is just wild when you think about the engineering behind it. There's also some cool work coming out of China with a company called Unitree. Their G1 humanoid robot, which starts at a price of $16,000 has been upgraded to do side flips and even jogs now after what they call an agile upgrade. You might remember that their earlier model, the H1, was the first of its kind to perform a backflip using electric motors instead of hydraulics. Even though the G1 is smaller and cheaper, it shows how different teams are pushing the limits of what humanoid robots can do. While Unitree's work is impressive in its own right, Atlas from Boston Dynamics has been in the game much longer and is still leading in terms of natural and dynamic movement. A big part of why Atlas can move so smoothly is the use of reinforcement learning. Basically, engineers run thousands of simulations where the robot tries different moves and it gets rewarded for successful actions. Over time, it learns to perform tasks like running, crawling, and even doing a cartwheel more naturally. The process is a bit slow because each move has to be simulated and refined, but it's all about teaching the robot how to balance and adapt to different environments. Now, Atlas isn't the only project that's getting a major boost. Boston Dynamics recently teamed up with the Robotics and AI Institute, RAI, to take things even further. This partnership, which started back in January, is all about making Atlas's movements more dynamic and human-like by improving the way it learns in simulated environments. In these simulations, every time the robot performs a move correctly, it earns a reward, which helps it figure out the best way to move in the real world. Because of this approach, Atlas can now do a sideways roll on the floor, perform a handstand with more ease, and even do a cartwheel with better precision. The team's focus has been on making every movement safer and more efficient, something that's become really important now that many companies are working on using robots in practical, everyday tasks. Back in 2022, Boston Dynamics and a few other robotics companies agreed that their robots would not be armed, and that decision continues to guide how these machines are developed for industrial and public safety roles. Now, Atlas can bend its legs backward and recover from a prone position with surprising ease. It can also rotate its head and torso a full 180 degrees. These moves are made possible by combining reinforcement learning with advanced models that let the robot adapt to more complicated environments. For example, the robot can reach into cluttered spaces or navigate around obstacles without missing a beat. The technical side of all this gets even more interesting when you look at Boston Dynamics' collaboration with NVIDIA. Atlas now runs on NVIDIA's Jetson Thor computing platform. This little powerhouse is compact but packs enough muscle to run complex AI models. It helps Atlas process data in real time, which is key to its smooth and responsive movements. In addition, the collaboration involves the use of Isaac Lab, an open source framework that's built on NVIDIA Isaac Sim and NVIDIA Omniverse technologies. Aaron Saunders, the Chief Technology Officer at Boston Dynamics, has talked about how this kind of integration is essential for bridging the gap between what happens in a simulation and what the robot does in the real world. Boston Dynamics is also rolling out new AI capabilities for its other robots, like Spot, their well-known quadruped, and Orbit, which is their software system for managing fleets of robots and analyzing data. Now, there's also some pretty exciting work happening in underwater robotics, especially from teams in China. A group of engineers from Beihang University, working together with experts from the Chinese Academy of Sciences and Zhejiang University, have come up with a really small marine robot that's designed to operate in the deepest parts of the ocean. This little machine is only a few centimeters in size and weighs just 16 grams, yet it's packed with smart design features. The robot uses a soft actuator that relies on a snap-through action, which lets it change between two stable modes. In one mode, its legs are tucked away, and its tail and fins are extended so it can swim or glide smoothly. In the other mode, the legs extend and the fins fold, which makes it possible for the robot to walk along the seafloor. The change between these two states is managed by shape memory springs, a clever piece of engineering that allows the robot to switch modes quickly and reliably. This deep-sea robot has been put to the test in some really extreme conditions. One of the trials was conducted at the Haima cold seep, where it operated at a depth of 1,384 meters, 4,540 feet. In another test, it was sent into the Mariana Trench and managed to work at an incredible depth of 10,666 meters, 35,000 feet. The same tech behind its movement was also used to create a soft gripper, allowing it to safely pick up live creatures from the ocean floor. Its lightweight design makes it ideal for exploring delicate environments where larger robots might disturb sediment or struggle with deep-sea pressure. All right, now, there is a new AI-powered robot developed by researchers at the University of Edinburgh that can make coffee in a busy kitchen, marking a big step forward in intelligent machines. Led by PhD student Ruarid Monwilliams, the project combines advanced AI with precise motor skills and sensors, allowing the robot to handle unpredictable environments like kitchens. Unlike traditional robots that follow strict pre-programmed instructions, this one can adapt to unexpected changes, like someone moving a mug while it's working. The robot, equipped with 7 movable joints, interprets verbal instructions, analyzes its surroundings, and even figures out how to open unfamiliar drawers to find what it needs. By blending reasoning, movement, and perception, the team's work highlights the growing potential of robots to manage everyday tasks that once seemed impossible. Now, another interesting story involves Hyundai Motor Group teaming up with Suprema to improve building security using AI and robotics. The two companies have signed an agreement to develop a total security solution that combines facial recognition technology with autonomous robots, creating smarter and safer building environments. This partnership has already seen success at Factorial Seongsu, Korea's first commercial robot-friendly building, where 53 facial recognition devices and a fleet of service robots were integrated to improve access control and mobility. The idea is to make security systems smarter by allowing robots to navigate freely through automated doors, speed gates, and elevators without manual intervention. By combining Hyundai's robotics expertise with Suprema's biometric security solutions, they aim to create a new standard for robot-friendly spaces. The project will also explore AIoT technology to improve services like food delivery and package handling within these smart buildings. Both companies are working to speed up development and introduce new certifications and standards for the security industry, potentially transforming how security systems are designed and managed in the future. Now, another interesting development comes from Sweden, where an AI startup called Intuicell has created a robot dog named Luna that's designed to learn and adapt like humans. Unlike traditional robots that rely on large data sets or offline simulations, Luna operates using a digital nervous system that allows it to develop naturally through real-world interactions. Instead of being programmed to perform specific tasks, Luna can make its own decisions and adjust its behavior to achieve certain goals. To train Luna, Intuicell took a different route by hiring a professional dog trainer to teach the robot how to walk. According to CEO Victor Luthman, this system doesn't require massive data centers or extensive pre-training. Luna is already able to stand and move on its own, and its abilities will continue to improve as it interacts with the world around it. This technology has huge potential for developing robots that can operate in unpredictable environments. Robots like Luna could one day be used for deep-sea exploration, disaster response, or even building habitats on Mars, all without the need for extensive pre-training to handle every possible scenario. Westwood just unveiled a humanoid robot that can run at 10 kilometers per hour, balance on rough terrain, and react 1,000 times per second. Meanwhile, 1X is showing off a robot that loads dishwashers, picks up leaves, and places pillows completely on its own. These aren't just flashy demos. This is the next phase of robotics, and it's moving fast. Let's start with Westwood Robotics' Themis V2. This thing stands around 5 feet 3 inches tall, so picture a life-size robot that's pretty close to your height if you're of average stature. One major headline feature is its 40 degrees of freedom. That just means it can bend and twist in 40 different ways. The arms have 6 degrees of freedom each, and the hands, or end effectors, bump that number up by 7 for finer movements. It's a second-generation model, so Westwood clearly built upon their first iteration to make it more fluid and capable. One reason it's become so fluid is that they upgraded the arms, giving them better articulation, so the robot can handle tasks that require a good amount of dexterity, like carefully picking up objects. Now, under the hood, Themis V2 features something called BEAR actuators, which stands for Back Drivable Electromechanical Actuator for Robotics. The back drivable part means it can smoothly move a joint in both directions without that jerky mechanical motion you sometimes see in older robots. It makes the movements more lifelike and, importantly, safer when operating around humans or delicate objects. If the robot accidentally bumps you, it doesn't feel like getting whacked by a car door. It's more controlled, with enough awareness to sense resistance and adjust accordingly. Powering all that brainy stuff is the robot's AI computing capability, which apparently cranks out around 200 pops. That's tera operations per second. In plainer language, that's a ton of computing horsepower. Because of this serious processing ability, the robot can run advanced machine learning algorithms right on board, letting it respond more quickly to changes in its environment. Speaking of changes in the environment, it also has a neat little gadget for balance and motion tracking, the 3DM CV7 AHRS sensor from MicroStrain by HBK. That sensor basically makes sure the robot knows exactly how it's tilting or turning up to 1,000 times every second. Picture it almost like an inner ear on steroids, giving the robot a constant stream of orientation data so it can handle uneven surfaces, stairs, or any random obstacle that might pop up. Combine that with the robot operating system, or ROS, and you get a super flexible software framework that allows developers to teach the robot new skills or tweak how it behaves in specific scenarios. Westwood claims their new humanoid can walk about as fast as a typical human, and they've even clocked it running up to 10 kilometers per hour, which is roughly 6.2 miles per hour. So if you decide to go for a jog, this robot could technically keep pace. They've been showing off some of its more extreme moves, like running, maybe even trying out a little parkour or jumping over low obstacles. The big takeaway is that they're designing this machine to handle real-world situations, not just theoretical test labs. If it's truly stable when the floor gets a bit rough or when it has to pivot quickly, that's a huge step forward in humanoid robotics. While Westwood focuses on a super capable humanoid that looks poised for tasks anywhere from industrial environments to more personal applications, there's also 1X's robot called Neo, which is being aimed straight at your home. The vice president of AI at 1X has been posting online about how Neo is picking up leaves, loading dishwashers, and even rearranging pillows on a couch. Now, maybe that sounds mundane. Oh, it's just picking up leaves, big deal. But it's actually pretty significant to see a robot autonomously spot leaves, scoop them up, and drop them into a bag without a remote operator. Autonomy is the magic word, folks. It's easy to show off a slick video of a robot moving around if someone behind the scenes is controlling it, but 1X claims that Neo is actually doing these tasks all on its own, making decisions in real time based on what it sees, how it's positioned, and where objects are located. One of their demo videos shows Neo working on what is arguably one of the most annoying chores in any household: loading the dishwasher. It picks up a cup, transfers it from one hand to the other, aligns it with the dishwasher rack, and then places it in there. It might not sound super flashy, but think about how many tiny calculations go into that, figuring out the shape of the cup, ensuring it's not too slippery, orienting it so it fits in the right slot, and making sure the robot itself stays balanced while bending over. In the video, the dishwasher was already open, and the cup was just sitting there, so it wasn't exactly reinventing the wheel, but it's a perfect example of the baby steps, or should I say robot steps, needed to tackle the chaos of a home environment. Another scenario they showcased was the robot walking over to a couch, picking up a cushion, and placing it down neatly. It's pretty interesting to watch it keep its balance while leaning forward with the cushion, especially given that the cushion itself is soft and somewhat unwieldy. Anyone who's tried to get a toddler to place a pillow in a corner without toppling over might appreciate how many balancing corrections are needed. The 1X team emphasizes that these examples, while relatively straightforward, illustrate the complexity of real-life tasks. Homes are messy and unpredictable. You've got rugs, pets, children running around, and furniture that's never exactly where you left it. To perform tasks effectively, a robot has to handle all those variables without getting jammed up when something changes unexpectedly. According to the 1X vice president of AI, everything you see in their demos is driven by data and a comprehensive network that controls full body motions from the lower body to the arms and the spine joints. And they're using reinforcement learning, AR, for the lower body and merging that with the rest of the system to achieve graceful movements. He even draws parallels to the idea that a robust consumer solution, which in this case means for everyday household tasks, can ultimately generate extremely valuable data for training more advanced general-purpose intelligence. It's the same kind of argument that Tesla has used for its self-driving program. The more data you collect on ordinary roads with average users, the better your AI becomes at handling all those weird corner cases. If you try to confine your robot or your AI to some very specialized and controlled space, you might not get enough diverse data to level up the intelligence as quickly. This is why 1X is specifically gunning for the home environment first. They're calling it the final boss of robotics because it's an absolutely unstructured environment full of a never-ending list of tasks. If a company tries to tackle robotics in smaller, narrower contexts like a warehouse where everything's neatly arranged and predictable, that might sound easier at first, but ironically, you can end up in a situation where you're not exposing your AI to enough variety. In a home, one moment the robot might need to pick up a piece of laundry and the next it has to deal with the pet dog wandering into the room. Or it might have to open a jar of pasta sauce, then realize that the jar's lid is stuck and needs extra force. Those little scenarios provide an avalanche of new data, training the AI to handle unplanned events. The argument is that a highly unstructured environment could speed up the development of a general intelligence by constantly challenging the robot with fresh tasks. The folks at 1X are being real about where things stand. They're not claiming their robot Neo can jump from loading the dishwasher to doing laundry without hiccups. It's not there yet. But the idea is to let the robot keep trying, make mistakes, and learn from them, just like how AI models improved by collecting tons of data over time. They even compare it to self-driving structured environments like highways don't give you enough challenges to grow. Homes, on the other hand, are chaotic, which actually helps the robot get smarter faster. So yeah, between Westwood's Themis V2 packed with serious hardware, sensors, and AI muscle, and Neo, which is out here doing leaf pickup and placing couch cushions on its own, we're seeing major steps toward robots that can handle real life. It's still early, but these are the kind of breakthroughs that could one day give us general-purpose robots that do way more than just vacuum. Robots are getting real, like dangerously real. One of them just snapped mid-demo and started swinging at engineers like it was auditioning for a Terminator reboot. And while that clip set social media on fire, it's only the start. In China, a car company is putting life-sized blonde humanoids with ponytails and sunglasses into showrooms to sell vehicles. Over in Germany, a robotics company is rolling out a humanoid worker that runs 8 hours straight and costs less than a Tesla. Across the ocean, in California, Berkeley just dropped a $5,000 DIY humanoid you can print at home, and people are already tweaking it to walk better and live longer. Meanwhile, Hyundai is going full sci-fi, bringing Boston Dynamics Atlas robots onto the factory floor to build 300,000 electric cars a year. So let's talk about it. All right, now the viral robot freakout clip is already framed as a meme, but the clip itself is almost too on the nose to ignore. Source, the Belarusian TV outfit Nexta, which reposted factory security footage shot somewhere in China. The robot in question, a half-finished humanoid dangling from a construction crane like a marionette, was meant to be going through a routine motion range test. 2 engineers stood underneath, hands on tablets reading out servo IDs. Suddenly, every joint spiked. The bot windmilled its arms, kicked its feet, yanked the suspension line sideways, and slid its welded stand across polished concrete. A desktop PC smashed to the floor, a bucket of fasteners scattered, and both engineers scrambled out of reach while the crane hook groaned overhead. The whole tantrum lasted maybe 20 seconds, but it drew more than 100,000 views in 4 hours and spawned 69 comment thread jokes about Skynet. One viewer wrote, "Sarah Connor was feffing right." Another posted a gif of RoboCop's ED-209 falling downstairs, and a surgical resident admitted the scene reminded him that a Da Vinci console is just motors and firmware after all. That clip parallels a wave of headline-friendly prototypes China has paraded all winter. Pudu Robotics' D9 can walk at 4.5 mph, climb stairs, and take a hip check without tumbling. Clone Robotics' February demo of the proto-clone musculoskeletal android flexed synthetic tendons and promised it would one day cook, clean, and hold a conversation. Commenters loved the tech, but called the atmosphere dystopian. The outburst handed them fresh ammunition. It showed how violently a torque value can run away when the safety envelope isn't nailed down. Meanwhile, 500 kilometers west of Shanghai, Chery Automotive is leaning into the opposite mood: charm. The company, run out of municipal woohoo and building cars since the mid-90s, has decided its next showroom employee will be Mornine, a life-size blonde android wearing wraparound sunglasses and a ponytail. Chery partnered with a robotics outfit called AI Moga in June 2024 and demoed Mornine at last year's Shanghai Auto Show. This week, the robot reappeared on stage behind Chery International President Zhang Guibing in a lineup of identical units. Zhang told dealers the market for humanoids has more potential than vehicles and declared AI Moga is the real future for the Chery company. The price, roughly the same as a car, so figure mid-five figures, though any dealer willing to write a purchase order gets an undisclosed discount. Even at list price, 220 units are promised for delivery in 2025, and one is already greeting shoppers in a Malaysian dealership, dispensing bottled water with carbon fiber fingers and answering trim package questions in a pleasantly synthetic Alto. The shades aren't a fashion gag. They hide a surround view camera array that stitches 360 degrees vision, and every fingertip carries capacitive pads that can feel when a customer taps a brochure. A social media clip of Mornine's junk in the trunk dance routine at the Woohoo launch drew a comment section nearly as long as the robot's spec sheet. One top-rated reply wondered whether the corporate dress code needed updating for plastic blondes. If Chery is selling vibes, Iggy GmbH is selling spreadsheet math. The Cologne-based motion plastics company spent 15 years harvesting tribology data for low-friction polymers. Now it's packaging those parts into a full humanoid called Iggy Rob that undercuts almost every Western competitor. Headline number: 47,999 euros, roughly $54,500 at today's rate, which is a third the price of Agility's Digit and half the rumored price of Tesla's Optimus. Iggy stands 1.7 meters tall, but it doesn't walk. The torso bolts onto Iggy's Rebel Move autonomous mobile base, a wheeled platform with a 3-point bearing that can carry 50 kilograms of its own mass, plus 100 kilograms of payload. Two Rebel cobot arms sprout from the shoulders, each sporting a 6-axis harmonic gearbox stack, and Igus's bionic hands clamp payloads with polymer gears that never need grease. Navigation comes from a roof-mount LiDAR and paired 3D cameras at eye level. Runtime is 8 hours on a single lithium pack. The whole bundle talks ROS2, is CE certified for Europe, and slots into VDA 5050 fleet management dashboards that German factories already use for tuggers and pallet movers. Ingus's sales pitch is brutally practical. They'll ship an evaluation unit, let your team test it in a live cell, maybe at a reception desk, maybe clearing cutlery in the canteen, then fly in an engineer to tweak pick points. If the trial makes financial sense, you keep the robot and pay the invoice. All right, underpinning that confidence is a 3-step roadmap. The 2022 Rebel Cobalt arm proved the drivetrain. The 2023 Rebel Hand won an RBR 50 award for under $1,000 dexterity, and the 2024 Rebel Move AMR handled the powertrain. Iggy is just the pieces screwed together. Across the Atlantic, University of California Berkeley's robotics lab is taking the price war almost to hobby level. Their Berkeley Humanoid Lite project dropped complete CAD, firmware, and reinforcement learning scripts onto GitHub with an NSF grant tag. The robot stands 0.8 meters tall, call it a toddler, with 22 cycloid gearboxes. You can print on any home FDM machine that handles a 200 by 200 by 200 millimeter envelope. Hardware bill in the US comes to $4,312, sourced from Shenzhen, and it's $3,236. The costliest line items are 10 high-torque 6512 actuators at $188 each, and 12 lighter 5010s at $136 each. Control is a $120 Intel N95 mini PC pushing 4 1 megabit CAN 2.0 buses at 250 Hz. Power is a 6-cell 4000 mAh LiPo, giving 30 minutes of runtime. On paper, that looks anemic, but Berkeley's party trick is software. They trained a walking policy entirely in simulation and watched it transfer zero shot to real hardware. The release video shows the bot stepping off a lab bench, shrugging its shoulders, writing its initials with a felt tip, stacking foam cubes, and spinning a scrambled Rubik's Cube, solving will take firmware v2.0. The paper's appendix introduces a tongue-in-cheek performance per dollar metric. Peak joint torque divided by height, normalized by price. By that measure, the $5,000 platform outranks several six-figure commercial machines. Reddit's verdict is split. Half the commenters call it the Raspberry Pi moment for legged robots. The rest say the demo looks like toys from 2013 and warn that 3D printing gear teeth in PLA is a reliability nightmare. Either way, the repo's issues tab already hosts pull requests for longer pipe batteries and alternative gear ratios, which was exactly the point. Berkeley wants hundreds of garage tinkerers pushing the design forward without waiting for corporate roadmaps. If Berkeley is pushing from the bottom and Igu's from the middle, Hyundai is battering the ceiling. The Korean automaker closed its purchase of Boston Dynamics in 2021. Now it's folding the Atlas platform, yes, the parkour-doing celebrity robot, into a new factory complex in Bryan County, Georgia. The plant sits at the core of a $21 billion US investment package, $6 billion of which is earmarked for automation and mobility tech. Hyundai already deploys Boston Dynamics' four-legged Spot for inspection rounds. Bringing in two-legged Atlas units is a bigger leap. The goal is 300,000 electric and hybrid vehicles per year, feeding a plan to push a US production capacity from 700,000 cars this year to 1.2 million by the end of the decade. Hyundai hasn't said how many Atlases it's buying, but supply chain whispers point to tens of thousands of robots across multiple categories. Atlas's appeal is clear. It can step over conveyor tracks, climb stairs, and thread through weld booths designed for humans, which means Hyundai can retool software faster than it could repour concrete. Labor unions are publicly worried about job displacement, yet management argues that uptime and safety statistics will speak for themselves once the bots clock in. The welding cell of 2026 might look like a human tech with a tablet, 3 Atlas units hauling stamped panels, and a dozen fixed ABB wrists performing spot welds, a species mashup the industry has never seen at scale. So, with robots now selling us cars, building them, and occasionally throwing a tantrum mid-test, how long before one replaces you at work? The new AI humanoid DARWIN 01 just hit factory floors with a foldable torso, 28 motors, hot swappable tools, and a self-charging, self-replacing battery system that, in theory, lets it operate endlessly without human intervention. Gummate showed up at a metro station, casually switching from 4-wheel to 2-wheel mode to climb stairs and answer passenger questions. Then Sapphire, Pepsi's brand new humanoid spokesperson, started guiding shoppers with real-time speech and gestures, fully certified to operate across the United States, Europe, and Asia. And while all that was happening, MagicBot pulled off live multi-robot coordination, kicked a football into the top corner, and helped launch the biggest humanoid robot competition to date. This was not a product tease, this was a full-on rollout, so let's talk about it. Let's start with DARWIN 01 from Standard Robots in Shenzhen. It kind of looks like a slim robot torso riding around on a set of smart wheels, almost like a futuristic skateboard. But here's what makes it special. Those wheels are omnidirectional, which means it can move in any direction, and fast. It zips through tight warehouse aisles faster than most human workers, over 2 meters per second, which is basically a fast walking speed or a light jog. Even though it looks small, its upper body hides 28 individual motors that let the arms bend, rotate, reach into awkward spaces, and even fold back if it needs to get under something low. And when it comes to lifting things, it can handle up to 10 kilograms, which is more than enough for most of the small parts, tools, and boxes used in factories and production lines. What really makes it useful is how flexible it is on the job. The wrist is designed to quickly swap out different tools. So one moment it can be using a gripper to grab small boxes, and the next it can switch to a suction cup to lift lighter plastic bags. The robot constantly updates how it moves and grabs things using a mix of sensors, laser scanners, depth cameras, and even radar, all working together to help it understand the space around it. This allows it to avoid bumping into things like wires or walls and figure out exactly what it's looking at and how to interact with it. It moves around on its own, but if needed, a human operator can take over remotely using a virtual reality headset and control it in real time through a 5th-generation network. The connection is super fast with barely any delay, which is important for situations where the robot needs to do really precise movements like placing something inside a tight space. The power system also got an upgrade. When it runs low on battery, it can either quickly charge itself at a docking station, or if you go for the more advanced version, it can automatically swap its battery using a special drawer system. And when they say it can run for 12 hours, that's not just a guess. They actually tested it with a full shift. 8 hours of work moving items, followed by 4 more hours doing quality checks. It ran the entire time without issues, and they published the test results. But the thing that really puts DARWIN ahead of older robots with wheels is how easily it fits into existing systems. It can connect directly to the same factory software used to run other machines, like manufacturing execution systems and warehouse management platforms. That means it can receive tasks just like any other robot on the floor. It also connects to the same network that controls other mobile robots, so it can work alongside them, hand off items, or even ride on top of an automated cart if something heavier comes through. And the company keeps showing off the foldable torso, and for good reason. It's not just a gimmick. The spine of the robot can actually fold down so its head stays below the height of older overhead rails and beams still used in many factories. And even while folded, the robot stays stable, adjusts its center of gravity, and keeps moving at full speed. It is one of those smart little design decisions that only comes from people who have actually worked in real factory environments. All right, now back to China. Slide west across the Pearl River Delta and you bump into Guangzhou, where GAC Group's GoMate is pulling a very different trick. It can scoot like a quad-wheeled rover or pop up to walk on 2 wheels when the terrain narrows. Yes, 2 wheels, not legs. Think Segway balance, but stretched into a 5-foot 9-inch humanoid silhouette. In 4-wheeled mode, the machine is 4 foot 7 inches tall, ideal for seeing over waist-high barriers without blocking commuters. Metro staff at Xingangyong Station have already been using it for security and passenger questions. It rolls up a short flight of stairs, flips into bipedal mode, and keeps patrolling the platform without missing a beat. The entire act hinges on 38 degrees of freedom in the joints and a ridiculously stiff body shell that hides GAC's own all-solid-state battery pack. Solid state means higher energy density, but here the real win is safety. No flammable liquid electrolyte, and a respectable 6-hour window between charges. The company claims their dual-mode locomotion cuts total energy draw by more than 80% compared with classic servo-driven legged robots, and the math checks out when you look at the torque curves. Less current spike equals longer life for the cells, which is handy because GoMate is not staying in the lab. GAC's automotive lines plan to press it into inspection duty this quarter. A production robot crawling underneath a chassis, scanning welds, then popping up to read a barcode on the dash seems mundane, but doing that autonomously every 90 seconds is massive throughput. The roadmap is equally aggressive: pilot programs across multiple industries before the end of 2025, small volume runs in 2026, and full mass production beyond that. What fascinates investors is the worldview shift inside Chinese auto brands. BYD posted graduate job ads zeroing in on humanoid robotics, and Li Auto's chief executive officer straight up said there is a 100% chance they will dive in. The logic is simple. Cars already pack batteries, motors, and drive units, so the supply chain for humanoids is sitting right on the assembly line. If a metro station trial proves GoMate can cut security headcount or let a single supervisor manage multiple robots remotely, every provincial subway operator will place an order. On the healthcare side, the same balance system that keeps GoMate steady on a moving escalator translates nicely to hospital corridors where stretchers, intravenous poles, and visitors collide in ways floor-plan, computer-aided design cannot predict. Add the fact that GAC's solid-state cells recharge fast, and you realize a graveyard shift nurse could rely on a robot courier that never complains, never calls in sick, and docks itself at 4 in the morning for a 40-minute top-up. Now, while DARWIN and GoMate chase industrial paychecks, PepsiCo's Chinese marketing team decided robots can also sling soda. They partnered with Zhiyuan Robotics to rebadge an AggieBot A2 as the PepsiCo Sapphire, and yes, the bot rocks the blue and silver livery alongside a backlit logo on the chest. The underlying hardware stands 1.7 meters tall, tips the scales at 69 kilograms, and runs a multimodal large model that fuses speech, vision, and gesture inputs on the fly. In practice, that means a kiosk in a supermarket can ask the humanoid where the zero sugar cans are, the robot points the way, and then cracks a dad joke in near real-time latency. The crucial bit here is certification. AggieBot A2 just became the first humanoid to rack up China CR, European Union CE medical device, European Union CE radio equipment, and United States FCC badges simultaneously. That trio of regions covers almost every supply chain PepsiCo pushes product through, so Sapphire can legally demo in a Guangzhou hypermarket on Monday and fly to a Barcelona trade show on Wednesday without customs seizures. But I am wondering, when Pepsi makes a robot its brand ambassador, does that mean humans officially suck at being human? All right, now certs usually sound boring, but they make a real dent in the rollout curve. Analysts keep framing 2025 as the kickoff for mass production humanoids, and the numbers floating around are wild, anywhere from 4 to 10 million units shipped annually by 2035. When your robot already satisfies radio, medical device, and general safety directives, the sales guys stop worrying about paperwork and start arguing about stock keeping unit count. ZWen's engineers also plugged in a customizable knowledge base. A regional brand manager can dump store layouts, promo stock keeping units, and local slang into the robot overnight. Next morning, Sapphire not only knows that 3 choose 1 is a 3-for-1 bundle, but also which end cap the bundle lives on. PepsiCo execs claim the bot will bleed into digital social campaigns, and honestly, that makes sense. Why drop an influencer fee when your own machine can wave at a phone and chain into a WeChat mini program? Rounding out the week is a name you may have missed, unless you track Shanghai's tech scene, Magic Lab's MagicBot. A single unit is solid, but the real party trick is that they already got a small swarm of these humanoids collaborating last December. Think of 3 or 4 identical bodies sharing sensor data, so one can pass a box to another without human timing cues. At the Guangzhou Embodied Intelligence Conference, the crew staged a live relay. One robot lifted a bumper-sized part off a pallet, passed it to a second unit on a slope, and a third slotted it onto a demo chassis. Crowd went loud, not because of the lift weight, industrial arms do that every day, but because the robots choreographed in real life with no external motion capture. MagicBot is not locked to factories either. Showrooms, malls, and even tourist hotspots are booking trial units as human-sized guides. The software stack lets the bot switch from pointing out horsepower figures at a car dealership to explaining dynasty artifacts in a museum in about the time it takes to sync a new dialogue pack. And that adaptability dovetails with Zhangjiang Robotics Valley's master plan. Attract 50 key component players by 2027, build a full parts-to-platform ecosystem, and then light up service deployments citywide. The developer competition hosted more than 60 teams tackling tasks like barcode scanning, rubbish pickup, and battery hot swaps. And one of the crowd pleasers was a MagicBot penalty kicking demo. Seeing a humanoid backstep, angle its frame, and slot a foam football top corner is equal parts technical flex and marketing gold. The organizers want that vibe because they need investors who normally fund apps to realize hardware is finally nimble enough to iterate fast. The whole place buzzed with that post-proof of concept energy. Basically, nobody is arguing whether humanoids can do the job, only how quickly they will displace legacy gear. All right, so something big just dropped in robotics. Unitree, the Chinese company known for its G1 humanoid and those fast AI robot dogs, just launched a full-size humanoid robot called the R1. And it comes in at just $5,900, which is unheard of for a humanoid. Not 5 figures, not research-only access. This thing is actually available for regular people. You can just go online and order it. That's a massive deal, so let's talk about it. Now let's start with what this robot actually does. The R1 isn't some flimsy demo bot that barely moves unless it's plugged into a lab wall. It walks, runs, balances, does cartwheels, flips onto its hands, and even throws in a kung fu kick if you ask nicely. And no, it's not controlled with complex scripts or hard coding. It uses real-time AI-powered voice recognition, has built-in cameras for visual input, and can hold basic conversations. There's even a remote control, so if it starts acting weird or a little too confident, you can shut it down instantly. And it's not small either. The R1 stands at 165 centimeters tall, about 5'5", and weighs 25 kilograms, or 55 pounds, so yeah, roughly the size of a teenager, but don't let that fool you. This isn't some lightweight toy. It's built with serious industrial-grade components, and it shows. Every part of it, from the actuators to the outer frame, is designed for strength, precision, and flexibility. It moves with balance and control, whether it's walking over uneven terrain, flipping mid-air, or popping back up after a fall. That kind of mobility comes from having 26 degrees of freedom, basically 26 fully functional joints distributed across its body. You've got movement in the ankles, knees, hips, waist, shoulders, elbows, wrists, neck, all individually controllable, which gives the robot a full range of motion that's eerily human. This is what allows it to pull off fluid movements instead of clunky, rigid motions you usually see in budget bots. In Unitree's own demos, the R1 is shown doing handstands, cartwheels, fast directional changes, and recovering from falls without external help. And these aren't pre-scripted animations. It's doing this dynamically with real-time motor feedback and balance control. That level of agility comes down to custom direct drive actuators developed in-house by Unitree, which allow for fast, accurate torque control without wasting energy or overheating. Powering all this is a lithium battery that gives you about 1 hour of runtime per charge. It's not ideal if you're expecting 8-hour workdays out of your humanoid, but for this price range, that's a fair trade-off. It also charges pretty quickly, so it's not like you'll be stuck waiting around half a day to use it again. Still, there's no built-in system for autonomous battery swapping, something that UB Tech's Walker S2 can actually do, so you'll need to manually plug it in or have a spare battery ready to go. But let's be real, the tech for hot swapping batteries and extended run times already exists. The only reason it's not in here is because they're keeping it affordable. They've clearly made the decision to strip out some of the convenience features in favor of core functionality, which, for early adopters, is the smarter call. And honestly, it's just a matter of time before we see those upgrades trickle into future versions or even as modular add-ons. The foundation is already here. And here's where things get especially interesting. The R1 isn't locked down. It comes with a fully open software development kit, meaning developers can dig into the system and build on top of it. You want to train it to recognize objects, build a new gesture system, turn it into a walking assistant, lab guide, or classroom tutor? You can. You've got access to the robot's motion controls, sensors, camera feeds, and voice modules. You can use Python, C++, or even plug into Robot Operating System if you're building something more advanced. That's a huge deal because most robots in this price bracket are walled gardens. Either they're pre-programmed with limited functionality, or you have to reverse engineer your way in. With the R1, Unitree is handing you the keys from day one. So what you're getting here isn't just a demo unit to watch dance for 5 minutes. You're getting a working, customizable humanoid platform with real-world potential. Now let's talk about the price again, because that's where Unitree really flipped the table. Their older humanoid, the G1, launched last year for $16,000. Their big industrial model, the H1, lists at over 90,000. And yet here comes the R1 running on similar tech stacks, doing flips and voice commands for under 6,000. For comparison, Tesla's Optimus isn't even out yet, but Elon is aiming for under 20,000 once production scales.
The price of Optimus, I mean, ultimately, I think Optimus is probably like $20,000 or something like that, maybe 30.
Apptronic's Apollo, Boston Dynamics Atlas, Agility Robotics, Digit, Figure 02, they're all sitting way higher. Atlas is around 100,000, Digit costs up to 250,000 depending on the client. Even cheaper open source options like Hope Jr. are more community projects than real products. So yeah, R1 is completely changing the pricing conversation, and you better believe that's putting pressure on every American and European robot company still figuring out how to make this kind of hardware affordable, because Unitree didn't just make something cheaper, they made something that works. It's agile, balanced, responsive, and honestly kind of scary in how nimble it is for the price. The company's been very clear about the audience, too. This isn't just for robotics labs or car factories. It's not some proof of concept that's going to collect dust on a conference stage. They're selling it to developers, tech enthusiasts, research teams, and even schools. And yes, regular people can buy one too if they want. You don't need to be a corporation or a university with $1 million grant. All you need is a solid reason and a spare $6,000. And people are already thinking about what they can do with it. Maybe it greets visitors in a hotel lobby, helps out with education in schools, or acts as a lightweight research assistant in universities. Some are thinking bigger: home assistants, elder care support, personal companions, entertainment bots. None of those use cases are fully ready yet, but the potential's obvious. For example, it could help someone grab meds from a high shelf, respond to voice requests, or even just provide company with simple conversation. And when your friends visit, maybe it shows off a backflip just for fun. It's not folding laundry yet, but we're not that far off anymore. The bigger point here isn't just the price or the features, it's the cultural shift that R1 could spark. For decades, humanoid robots were science fiction, reserved for movies, labs, and the occasional stunt demo at a tech expo. Now, one could literally stand next to your router at home. You're not reading about it, you're living with it. That changes things. Because when robots enter daily life, they bring questions with them about safety, etiquette, usefulness, privacy, even companionship. Unitree isn't ignoring that either. They've put out disclaimers reminding people that this thing is powerful, potentially risky, and not a toy. Keep your distance, don't make dangerous modifications, don't treat it like it's indestructible. There's a reason the manual has bold text about using the robot responsibly and understanding its limits. It's still early days, and even though R1 looks friendly, it's got serious hardware under the hood. People need to treat it with the same caution you would any powerful machine. Now, the timing of this release is also pretty strategic. The company just filed tutoring documents with regulators in China, an early step toward going public on the mainland stock exchange. If they stay on track, they might be the first pure-play humanoid robotics company to go public in China. That alone adds weight to the R1 launch. This is a serious initiative backed by a much bigger vision. Unitree wants to dominate the entry-level humanoid robot space the same way Xiaomi disrupted the smartphone world years ago. And honestly, the comparison fits. When Xiaomi dropped those ultra-budget phones, it wasn't just about price, it was about access. Suddenly, millions of people could afford tech that was once out of reach. The same thing is happening here. R1 is the first real humanoid robot to break below that psychological $6,000 barrier. It's not a gimmick or a stripped-down toy, it's the full package. Real legs, real arms, real AI, real functionality. And sure, it's not perfect. You only get about 1 hour of runtime per charge. You'll need to manually recharge or swap batteries. It's not babysitting kids or cooking dinner, yet. But what matters is that it's no longer just a lab experiment, it's a product. A real one, ready for use, ready for play, ready for development. And that's why this moment feels like more than just another tech launch. It feels like a threshold. A team of ex-Google and Tesla engineers just dropped an open source operating system that could turn every humanoid robot on Earth into part of a single connected hive mind, which could be the greatest leap in technology or the last mistake we ever make. A new $5,300 humanoid is built to live in your home, remember you, and adapt to your personality. And China is rolling out a $1 trillion plan to put intelligent machines in factories, hospitals, and homes across the country. Wild times for robotics, so let's get into it. Let's start with one of the most talked about launches, OpenMind and their OM1 operating system. This is a company built by former Google and Tesla engineers, and they're trying to do for humanoid robots what Android did for smartphones. Instead of every robot having its own closed, proprietary system that developers have to code for separately, OM1 is open source and hardware agnostic. That means you could have different robot bodies, from a warehouse bot to a humanoid assistant, all running the exact same intelligence without having to rewrite code for each one. The system integrates advanced AI models for perception, decision-making, and movement, so you're not just getting basic commands, you're getting adaptive, multimodal intelligence. The big twist here is their companion protocol called Fabric. Think of it as the communication layer between robots, a decentralized network where they can securely share what they learn. A robot in a hospital figuring out a faster way to deliver supplies could instantly pass that skill on to another unit halfway across the world. This isn't just about speed, it's about creating a hive mind of connected machines. And yes, there are serious security and privacy questions here because open networks are always a target, but the upside is huge if it works. They've just secured $20 million in funding to make it happen. Pantera Capital led the round, and even Pi Network, the crypto crowd, jumped in hinting at a possible blockchain element for trust and traceability in robot coordination. The founders are calling OM1 a plug-and-play OS for intelligent machines, and they've built it using Python under an MIT license. That makes it easy for developers to dive in, experiment, and deploy on everything from robot dogs to humanoids. And yes, they actually have a fleet of OM1-powered quadrupeds shipping next month, with a bigger rollout planned for October. What's interesting is how this could shake up the competitive landscape. Tesla has its in-house bot OS. Figure AI is running powerful open source vision language models on their Helix platform, and Boston Dynamics is still the gold standard for movement. But OM1's approach is more about building a massive developer ecosystem than trying to dominate hardware. They're even partnering with educational institutions to get OM1 into robotics curriculums, which could mean the next wave of robotics engineers grows up on this platform instead of a proprietary one. Now, Fabric is the real gamble here. It's inspired by blockchain, decentralized verification, secure data exchange, but the challenge is latency. Robotics needs real-time responsiveness, and blockchain systems historically don't do real-time well. Early demos look promising, but until we see it in high-pressure, unpredictable environments, it's still a question mark. October's broader launch will be critical. That's when OpenMind will need to prove that an open source ecosystem can outpace and out-innovate closed systems. If they pull it off, it could change the balance of power in robotics entirely. If they stumble, it'll just reinforce the idea that vertical integration is the safer bet. But real quick, if you've been following all this AI news and thinking, okay, this is cool, but what can I actually do with it? You're definitely not alone. That's why we created the AI Income Blueprint. It shows you 7 ways regular people are using AI to build extra income streams on the side. No tech skills needed, and you can automate everything pretty easily. The guide contains simple, proven methods using tools I often talk about on this channel. Download it free by clicking the link in the description. Now, while OpenMind is betting on software unification, Engine AI is coming from a completely different angle: consumer-friendly humanoids. They've just announced the SAO2, a humanoid that's 1.25 meters tall, 25 kilos, and costs $5,300. For perspective, that's cheaper than Unitree's R1, which starts at $5,900. The SAO2 isn't trying to be an industrial powerhouse. This is about personality, companionship, and fitting into your daily life. It's got 26 plus 2 degrees of freedom, so yes, it can move its fingers naturally, gesture when it talks, and do those little micro movements that make conversations feel human. Inside, there's a built-in large language model, so it remembers context, adapts over time, and even shapes its personality based on your interaction. It's not just spitting out scripted lines, it learns how you like to talk. Two HD cameras up front handle object detection, face tracking, and spatial awareness. The speakers are high fidelity, so when it reads you a recipe or plays music, it doesn't sound tinny or robotic. And because it's aimed at homes, it's light enough to move easily, and friendly enough in design that it doesn't look out of place in a living room. The guy behind Engine AI, Zhao Tongyang, used to run the Humanoid Robotics program at Xpeng, the EV giant. He left in 2023, launched Engine AI, and now he's competing directly with his old company. The SAO-1, their first model, came out in July 2024 and was aimed at education and research, priced around $5,400. The SAO-2 is lighter, friendlier, and far more geared toward personal and family use. They're teasing the full reveal at the 2025 World Robot Conference in Beijing, with pre-orders and global rollout to follow. While SAO-2 is about approachable companionship, Fourier's new GR3 takes emotional intelligence in robots to a whole other level. They call it a care bot, and it's built with something they've branded the Full Perception Multimodal Interaction System. That's vision, audio, and tactile feedback, all feeding into a real-time emotional processing engine. The R3 stands at 1.65 meters, weighs 71 kilos, and has 55 degrees of freedom. The design is soft touch, warm tones, automotive-grade upholstery, clearly meant to feel familiar, not industrial. The animated facial interface and natural gait give it a sense of presence rather than the cold detachment most robots still carry. What's wild is how it responds to human interaction. It can localize voices with a 4-mic array, lock eye contact, recognize faces, and detect touch through 31 pressure sensors. Touch its arm, and it might blink, subtly move its head, or react with an emotional gesture. It's running a dual-path brain, fast thinking for instant reflexive actions, and slow thinking that pulls on a large language model for deeper contextual conversation. It's built for real-world environments, homes, hospitals, elder care facilities, and can adapt its locomotion style to the situation. They even have modes like bounty walk or fatigue mode to make its movement feel more relatable. The battery is hot swappable so it can run continuously, and its modular design plus developer-friendly APIs mean it can be tailored for different industries. Fourier isn't selling it just as a product, they're pushing it as a platform for human-robot integration. All of these launches are happening right alongside a massive push in China to create a unified embodied intelligence ecosystem. Just a couple of days ago, at the 2025 World Robot Conference in Beijing, they held the Embodied Intelligence Industry Finance Ecosystem Cooperation and Exchange event. Quite a mouthful, but it's a big deal. This wasn't just a showcase. It was government officials, researchers, finance executives, and industry leaders all in one room, talking about how to take embodied intelligence from lab demos to nationwide deployment. They officially launched the Embodied Intelligence Professional Committee of the China Information Association, basically a permanent body to coordinate between government, academia, industry, and finance. Speakers hammered on the same themes. China's no longer just following global tech trends, it's leading in ecosystem building. They want to push embodied intelligence as the key way AI integrates into the real economy. Think of it as the nervous system for the next wave of automation. Not just single robots doing isolated jobs, but coordinated, intelligent fleets in manufacturing, logistics, healthcare, and even homes. There was a strong focus on breaking bottlenecks in technology, building a full chain ecosystem, and creating replicable deployment models. One of the standout points came from Wang Zhengqiao of the Chinese Academy of Sciences, who said that embodied AI brains face data scarcity and fragmented scenarios. His solution? Integrate simulation with real-world training to create closed-loop data systems so skills learned in virtual environments translate seamlessly into physical ones. Look, most people still think AI is some distant future, but regular folks are already using it to build income streams quietly, behind the scenes. If you want to see how they're doing it without tech skills or quitting their job, download the AI Income Blueprint. It's totally free, the link's in the description, but it won't stay free forever. On the finance side, CICC Capital projected embodied intelligence could be a trillion-level market after smart vehicles, potentially hitting 24.7 trillion yuan by 2050. They're positioning capital to accelerate commercialization, with banks like China CITD rolling out full life cycle financial services for robotics companies. Loans, investment loan linkage, the works. They even signed ecological cooperation agreements between companies like AUBO Intelligence, Shengxi Tianan, 9 Chapters Cloudpole, and Huishi Intelligence to build an embodied intelligent robot training ground. The idea is to have a standardized environment for testing and improving these systems with unified rules and data compliance baked in. Unitree's G1 now fights off hits with anti-gravity mode. A headform's humanoid head looks disturbingly real. Foria's N1 is flipping through kung fu moves, and Poland's Clone Robotics is showing off a corpse-like bot powered by synthetic muscles. All of this is happening while China quietly runs more than 2 million AI robots in its factories, assembling trucks in minutes and coordinating in swarms. It's equal parts exciting and terrifying, so let's talk about it. Let's start with what Unitree just pulled off, because this one is both hilarious to watch and actually really important. Instead of doing the usual polished lab showcase where a robot takes a few careful steps and everyone claps, Unitree engineers basically decided to kick the living daylights out of their G1 humanoid. And the crazy part is, it survived over and over again. The secret behind it is what they're calling anti-gravity mode. Now, it's not actual anti-gravity, obviously, but it's a whole control system focused on balance and recovery. Older humanoids, you hit them, they fall, and then it's like rebooting a clumsy toy. With G1, the moment a kick or shove comes in, it's already predicting how to land, how to brace, or how to step out of the way. And that's because the robot is loaded with depth cameras and 3D LiDAR. Those sensors give it this live map of the world, where it is, what's moving, what force is about to smack it, and then every joint packed with its own motor reacts almost like muscles firing in sync. One of the wildest moments in the demo is when someone delivers a proper side kick. Instead of face planting, the G1 just spreads its legs wide, leans into it, and regains control. It looks less like a machine glitching out and more like an athlete bracing for contact. Earlier in the clip, it takes a hit, folds its knees instantly to absorb the impact, then springs back up in one clean move, lifting its full 77 pounds with torque to spare. Later, they push it even harder, like running kicks that send it sliding across the floor, or double shoves that force it to adjust mid-air. Each time, it scans with LiDAR, recalculates, and just gets up again. That's the kind of resilience factories want. Because in an industrial setting, even a tiny disruption, like a robot needing a full reset, costs money and time. The G1, priced around $16,000, is actually on the more affordable side of humanoids. And Unitree isn't aiming this at YouTubers trying to go viral. They're looking at research labs and work floors where adaptability is everything. If it can take hits and keep going without someone rushing in to fix it, that's serious value. Now, here's where it gets even more interesting. Unitree's CEO, Wang Xingxing, revealed at the Global Digital Trade Expo in Hangzhou that the company isn't stopping at the G1. They are already preparing to launch a full-sized 1.8-meter humanoid robot in the second half of this year. And it's not just hype. Unitree has been iterating their algorithms at a crazy pace all year, and the Weibo teasers of this tall robot already drew massive attention. This fits right into a bigger trend across China's robotics industry. According to the Ministry of Industry and Information Technology, just in the first half of 2025, the industry's operating revenue went up 27.8% year-on-year. Industrial robot output alone jumped 35.6%, while service robots climbed 25.5%. Wang mentioned that companies in this sector are seeing average growth rates between 50 and 100%. That's not normal growth, that's an explosion. But Unitree isn't the only name making headlines. A company called A Headform has been doing something that honestly creeps people out. Instead of focusing on balance or cartwheels, they built a humanoid head that can express emotions so lifelike it actually startles people. In one demo video, the head glances around with a quizzical look, blinks naturally, and basically gives you the chills because it's so human-like. Their whole philosophy is that better interaction means giving robots expressive faces, moving eyes, synchronized speech, subtle facial cues, so humans feel like the robot actually understands. They call their lineup the ELF series. And yes, they literally give these robots elf-like designs with big ears. Some of the models even packed 30 degrees of freedom just in the face, driven by an advanced AI learning system and high DOF bionic actuation. The latest one, called Zuon, is a full-body figure with a static torso but a head that can pull off a massive range of expressions and lifelike gaze behaviors. Another, Elf V1, supposedly perceives, communicates, learns, and interacts intelligently with its environment. The trick here is a brushless motor designed specifically for facial control. It's ultra quiet, super responsive, lightweight, and energy efficient, perfect for making those tiny muscle-like movements we rely on to judge emotion. The founder, Hu Yuhong, is ambitious. He predicts that in 10 years, robots will feel almost human when you interact with them, and in 20 years, they'll walk and perform tasks just like us. He's realistic, though. He admits making a robot truly identical to a human is insanely hard. Meanwhile, other Chinese companies like Shanghai Qingbao Engine Robot are already selling androids that look disturbingly real, mainly to attract attention in public spaces, retail, hospitals, schools, hotels, even e-commerce live streams. But for most of the industry, the real focus isn't emotions, it's productivity. Tesla, Unitree, Fourier, all of them are building humanoids to work. Speaking of brutal testing, let's move to something that honestly shocked a lot of people. A startup called Skilled AI put out a demo where an engineer literally takes a chainsaw to a robot dog's legs. You'd think that would be the end of it, right? Nope. Their AI brain just keeps the thing moving. Even with all 4 limbs hacked off, the bot somehow hobbles around. It looks disturbing, but it proves a big point. Skilled calls this system an omni-bodied robot brain. Basically, instead of programming an AI to control one specific robot, they trained it across a universe of 100,000 different robot bodies. That way, the AI can't just memorize solutions, it has to figure out strategies that work no matter what body it finds itself in. Broken wheels, missing legs, walking on stilts. The AI adapts. They trained it to the point where even when reality throws a scenario completely different from training, it still copes. Their claim is that this shows early sparks of intelligence in the world of atoms. And if you think about where that leads, robots that can adapt to any body, any damage, that's the kind of flexibility you'd want in hospitals, homes, or factories. It's like decoupling the mind from the body. Some researchers, like Jeffrey Ladish from Palisade Research, think this points to a future where AI surpasses human strategy at the same time robotics surpasses human physical performance. And then, of course, combine them. The scary part is if we keep treating robots like disposable test subjects, kicks, chainsaws, dragging them with chains, you start to wonder what happens if they ever actually outsmart us. Now let's jump to Shanghai, where Fourier is showing off the N1, also called Nexus 01. This is a smaller, lighter humanoid designed as an open source platform, and they just put out a demo that looks like a kung fu routine. The N1 pulled off a full cartwheel and even a 360-degree jump spin. Watching it land cleanly is impressive because those are not easy moves for humanoids. Fourier's history is mainly in rehab robotics, but with the GR series, GR1, GR2, GR3, they moved into full-size humanoids. The GR1, for example, weighs 55 kilograms and has 44 degrees of freedom. The later GR3 leaned more toward companionship. But the N1 is a shift in philosophy. It's 1.3 meters tall, about 38 kilograms, made from lightweight aluminum alloy and engineering plastic. It runs more than 2 hours on a charge and can sprint at 3.5 meters per second. The real kicker, though, is that it's open source. Fourier provides blueprints, software, control systems, even the bill of materials. Universities, labs, hobbyists, they can all tinker with it. You can buy self-assembly kits or ready-made versions as part of what Fourier calls their Nexus Open Source Ecological Matrix. And while the cartwheel is obviously meant to grab attention, it's also a sign that this robot can handle dynamic forces, balance recovery, and high-stress moves without breaking. In terms of market positioning, Fourier is putting itself right next to Unitree's H1, G1, and the new $6,000 R1, as well as Boston Dynamics Atlas that pioneered backflips and parkour. Now over in Poland, Clone Robotics is back in the spotlight with its humanoid prototype, Protoclone. Unlike the sleek designs of many rivals, this machine has drawn attention for its unsettling corpse-like look, shown in a recent video where it twitches while suspended by cables. Founded in 2021 by CEO Danush Radhakrishnan, the company took a biomimetic path, first developing a robotic hand with artificial ligaments and myofiber units that mimic muscles and tendons. Within a year, this work expanded into a full humanoid powered by fluidic muscles and a compact hydraulic heart pump. Equipped with sensors for torque, position, and force, and running on NVIDIA Jetson chips, Protoclone is being followed by a next model called Neoclone, expected to add tactile skin for more delicate tasks. And zooming out from individual robots, China has now pulled far ahead in global robot deployment. Factories there run with over 2 million industrial robots, more than the rest of the world combined. A decade ago, density was 49 robots per 10,000 workers. Today, it's 470. This surge comes from heavy state investment under Made in China 2025, including billions in R&D and acquisitions, like Germany's KUKA in 2016. Last year alone, nearly 300,000 new robots were installed. These aren't simple machines either. They handle predictive maintenance, real-time decisions, and collaborative work. In Shanghai, humanoids fold clothes and prep food using datasets like AggieBot World, while factory models such as DeepSeek R1 enable swarm intelligence over 5G. Some startups are already assembling electric trucks in just 15 minutes, and robots like Tiangong compute at 550 trillion operations per second. In 2024, the electronics sector added 83,000 units, with automotive right behind. But experts warn this growth also means job displacement, with Tsinghua University predicting semi-automated lines could become fully intelligent within 5 years. Boston Dynamics just gave its Atlas robot a new pair of hands, and they might be the most advanced robotic hands ever built. At the same time, Figure AI unveiled its next-generation humanoid that can literally wash dishes, fold laundry, and charge itself. The race to build the first humanoid robot that's actually useful is reaching a tipping point, and the breakthroughs happening right now might decide which company defines the next era of automation. So let's talk about it. All right, let's start with Boston Dynamics. They've just given Atlas a major upgrade. You've all seen Atlas before, the bipedal robot famous for its backflips and parkour routines. Well, this time the focus isn't on how it moves, but on how it handles things. The team's been working on giving it real human-like dexterity, and the result is a brand new second-generation gripper called GR2 that completely changes what Atlas can do with its hands. Backstory: when Atlas switched from hydraulics to full electric, it gave Boston Dynamics a chance to rethink what the hands could do, not just worry about legs and locomotion. That shift created an opening to focus more seriously on manipulation, grabbing, holding, twisting, releasing. Grippers are deceptively tricky. You need actuation, sensing, all crammed into a small package. Because of that, Boston Dynamics took a long-haul view. The first version, GR1, had 3 fingers in a line, no thumb, and taught them a lot about mounting, ruggedness, and failure modes, like when the robot falls on the hand. Now, GR2 is the step forward. This new GR2 gripper has 7 degrees of freedom. That is 7 actuators, 2 per finger for 3 fingers equals 6, plus 1 extra actuator for an articulated, opposable thumb. That thumb is a big deal. Without a thumb, the robot's grasp options are much more limited. With the thumb, it can do 2-finger pinches, 3-finger grasps, and stabilize heavier objects by distributing force among fingers. But it's not just about moving parts. The gripper includes tactile sensing in the fingertips. Think of that as the robot's sense of touch. Under an elastomer surface, sensors detect deformation, so the control system knows how much force is being applied. That allows the gripper to apply just enough force to hold something stably without crushing or dropping it. And if something slips or falls, the sensors pick that up. The gripper also has cameras in the palm. a visual backup in tight places where the main vision system might be occluded. Mechanically, each gripper module is self-contained. All actuation is inside it, so you can mount or remove it easily. It's designed with some ruggedness in mind because sometimes the robot might fall or land partially on the hand. The designers considered that and built in robustness to survive those events. Moving from GR1 to GR2, the biggest change is that thumb. GR1's 3 fingers were aligned, no thumb. GR2 adds the thumb, which dramatically increases what the hand can handle. They debated whether to add more fingers, but more fingers equals more complexity, reliability problems, costs, development speed issues. So for now, 3 fingers plus a thumb was judged to be the sweet spot for manipulation, dexterity, and practicality. And with that, they say Atlas can grasp almost anything thrown at it. Everyday, irregular shapes, tools, variable objects, much more flexibly than before. That new dexterity is critical because many tasks robots are heading toward involve not just strolling or walking, but actually interacting with items, bin picking, tool use, wiring, quality inspection, or small delicate object handling. The opposing thumb enables pinch grasps. The extra finger helps stability when rotating heavier or larger objects. The fingers can also bend backwards fully, allowing some clever grasping on the backside of objects. There are left and right versions of the gripper, mirrored, so the thumb always comes around on the same side for each hand. Also, Atlas plans action strategically. If the left hand gives a more stable grasp in a given pose or avoids obstacles, it uses that. It does not adopt a fixed dominant hand like humans. The development path is about gradually raising the bar in dexterity. The designers foresee that over time, a sweet spot in actuation, sensing, and physical design will emerge, and that the field will naturally drift toward more anthropomorphic designs as tasks demand it. Now couple that with what Boston Dynamics is demonstrating more publicly. In new demos, this upgraded Atlas can pick up irregular shapes, adjust its grip in real time, thread a needle, assemble components, and manage objects with fine control. This is not just strength or brute force, it's nuanced manipulation. With that opposing thumb and tactile feedback, the hands can do much more subtle tasks. It's one thing to grip a block, it's another to reorient, twist, adjust, or delicately place. But there are still a few major hurdles ahead. And safety is right at the top of that list. In one viral incident, a similar robot, a rival, flailed during testing, reminding everyone how failure modes can be dramatic. Boston Dynamics has emphasized rigorous testing, balance strategies, and fallback modes to mitigate that risk. You don't want a giant robot accidentally crushing bones or machinery because it lost stability. On the broader industry front, Boston Dynamics is racing against rivals like Tesla's Optimus and Unitree. For instance, Unitree's G1 model is known for its anti-gravity recovery. If it falls, it rebounds. Those dynamic recovery capabilities could complement dexterous hands like GR2. And Tesla has shown off Optimus doing balancing or controlled motions, presumably heading toward fine manipulation. Another competitor pushing a different angle is Figure AI with its new Figure 03 Humanoid. They are aiming for general-purpose robots, not just industrial, but usable in homes, hotels, warehouses, etc. Their pitch is that they're going beyond lab demos into real deployment. Figure 03 has several improvements. First, it uses their in-house AI system Helix, vision language action, to learn tasks by interacting directly. They claim nothing is teleoperated. The new model is lighter, 9% mass reduction over Figure 02, and shrunk in footprint. Its external design eliminates exposed metal parts, adds soft washable covers, and uses padding to reduce risk in pinch areas. Because when these operate around humans, soft external materials help with safety. They also increased their sensor field of view. Each camera has about a 60% wider field of view. They also doubled frame rates, cut latency by 75%. Cameras are built into each palm to help when the main eyes are blocked, for example, reaching into a cabinet. Palm cameras give additional visual feedback to guide grasping. On tactile capability, Figure 03 uses custom touch sensors in the fingertips. Off-the-shelf sensors weren't robust enough. The sensors are claimed to detect minute pressure changes, sensitive enough for something like the weight of a paperclip. Fingertips are made of softer material for steadier grip. The robot stands about 1.68 meters tall. That's roughly 5'6", weighs around 60 kilograms or about 130 pounds, can carry up to 20 kilograms, which is 44 pounds, and moves at about 1.2 meters per second or around 2.5 miles per hour. Battery life is up to 5 hours per charge, and charging is wireless via floor plates up to 2 kilowatts. The robot docks itself. They've also geared their manufacturing towards scale rather than fully custom machined parts. Many components are made by die casting, injection molding, stamping to reduce cost and speed up production. They aim to produce 12,000 units per year to start, with a 4-year target of 100,000 units through their BotQ facility in San Jose. That's ambitious. Scaling gives them leverage in cost, repair, supply chain. In terms of tasks, they show the robot doing dishes, interacting with human appliances, working at a reception desk, navigating stairs, handling changing layouts, even doing chores via voice commands. But the coverage from tech journalist David Zondi points out that while the demos look impressive, they still come from controlled company environments, so it's hard to know how the robot would actually perform in a real home full of obstacles, pets, and unexpected mess. Basically, there's no independent benchmark results yet. The real test is how these systems perform in messy, unpredictable real homes with kids, pets, obstacles, unmodeled surfaces. That reality gap is a classic issue. Robots in controlled labs look great. In the real world, things are full of surprises. From Boston Dynamics' side, integrating their hand capabilities, tactile sensing, thumb, sensor vision, could help robots like Atlas tackle tasks that are currently human domain. The modular nature of the GR2 design means you could swap gripper modules or adapt to specific tools, and coupling that with powerful computation like NVIDIA's Jetson Thor chip, which is described by some as a platform for physical AI, might boost the AI that drives these systems. The robot needs to see, plan, react, adapt, all in real time. That means high compute, efficient perception models, robust control loops. The competition is intense though. Tesla's Optimus has shown off balance and motion capabilities. Climbing robots with claws are pushing the envelope in physical repertoires. But Boston Dynamics grippers stand out because of human-like finesse, enabling tasks that demand subtlety, threading, wiring, manipulation of thin or delicate objects. Meanwhile, Figure AI is betting on combining generalized intelligence, Helix, with improved hardware to bring humanoids into homes and small businesses. One tension is how far robots will replace human labor versus augment it. The promise is that they'll take over repetitive or dangerous tasks, freeing humans to supervise, manage exceptions, innovate, but job displacement concerns will inevitably emerge. That said, right now these robots are expensive and complex. They augment more than replace. Let me close out. Every few months it feels like robots level up again, and this time they've gone from doing tricks to actually doing work. The line between demo and deployment is getting thin, and that's when things start to get interesting. So, what's your take? Are we ready for this new wave, or are we moving a little too fast? Drop a comment, leave a like if you enjoyed it, and subscribe for more deep dives. Thanks for watching, and catch you in the next one.